Hey, this is Presh Towalker. This final exam question has gone viral because the details of this story feel oddly specific, as if the teacher is going through a breakup. On a rainy day, a girl broke up with her boyfriend after being together for 8 long years. They decided to separate at the place where everything about them began at the same time. The boy is due north, crying and running at a rate of 5 feet per second, and the girl is walking due east at the rate of 1 foot per second and thinking if she made the right decision. How fast are they separating from each other 2 seconds after they started moving to a new life without each other? So how can we solve this problem? Let's get started by sketching a diagram. Here's the point at which everything began. The boy is running due north, crying, and running at the rate of 5 feet per second. The girl is walking due east and thinking about what happened, and this is happening at a rate of 1 foot per second. So the distance between them will be the length of the line segment of the endpoints of these vectors. So we want to see how fast this distance is changing over time. So let's just imagine we have a discrete problem, and let's work out some times. So let's start out where t is equal to 1 second. The boy will have run 5 feet per second for 1 second, so this will be 5 feet. The girl runs 1 foot per second, and this is 1 second, so this length will be equal to 1. We now have a right triangle with legs of 5 and 1, so we can calculate the length of the hypotenuse, which will be the distance between them. This will be equal to the square root of the quantity, 5 squared plus 1 squared, which simplifies to be the square root of 26. So let's set up a table where we have the time and the distance between them. At a time of 1, the distance is equal to the square root of 26. Now let's go to t is equal to 2. The boy will have moved a distance of 10 feet, and the girl has moved a distance of 2 feet. We have another right triangle, so we can calculate the length of the hypotenuse, which is the distance between them. This will be equal to the square root of the quantity, 10 squared plus 2 squared, and this simplifies to be 2 multiplied by the square root of 26. So now let's go to another value. Let's imagine t is equal to 3. The vertical distance will be 5 times 3, which equals 15. The horizontal distance will be 1 times 3, which equals 3. We then calculate the length of the hypotenuse, which will be the square root of the square of 15 plus the square of 3. This works out to be 3 times the square root of 26. The problem is asking for how fast they are separating from each other. This will be equal to the change in distance divided by the change in time. We want to know how quickly the distance is changing. So we will calculate a new quantity, the change in distance. Now going from 1 second to 2 seconds, we will have a change in distance of the square root of 26. Going from 2 seconds to 3 seconds, we also have a change in distance of the square root of 26. Each time interval will be a delta t of 1 second. So we need to calculate the change in distance divided by the change in time. This is equal to the square root of 26 divided by 1, which equals the square root of 26, which is approximately equal to 5.099. In this particular problem, it appears the distance is changing linearly with time. So this delta d over delta t calculation does work out to be the correct answer of the square root of 26, or approximately 5.099. But this so far, what we've done is a discrete estimate. The question was given in a calculus class, so let's find the answer using differential calculus. So let's start out in the general case where we have a variable time. The vertical distance will be 5 multiplied by the time. Then the horizontal distance will be 1 multiplied by the time, which works out to be t. We can calculate the length of the hypotenuse. This will be the square root of the square of 5t plus t squared. This works out to be the square root of 26t squared. Since we have a positive length, we just want to deal with the absolute length of this line segment. This works out to be t multiplied by the square root of 26. We don't have to worry about negative distances here. So now we have a distance function as a function of the variable t, which is equal to t multiplied by the square root of 26. We take the derivative with respect to t, so d prime of t is equal to the square root of 26. We need to know how fast they are separating at a time of 2 seconds, so we evaluate the derivative at t is equal to 2. This gives d prime of t is equal to the square root of 26, and this is approximately 5.099 feet per second. And that's the answer. So in evaluation, this is probably not the most difficult question because the derivative is a constant. They are always separating at the same rate of the square root of 26 at any given time. But a student who is asked to evaluate the derivative at t is equal to 2 seconds may wonder that this is too easy of an answer. So it's something of a trick question to ask to evaluate at t is equal to 2. But in any case, the correct answer is that they are separating at a rate of the square root of 26, or approximately 5.099 feet per second, and that is constant regardless of which time you ask the question. Thanks for making us one of the best communities on YouTube. See you next episode of Mind Your Decisions, where we solve the world's problems, one video at a time.